knowledge makes you great.
It's been 25 years of passionate chasing.
Hello everyone, Namaste. This is Anand Krishnan here, and here we are ready for the takeoff of our all new series, Hamara Tejas. Co-piloting with me is the one and only Dr. Kota Harinarayana, the man who has seen light combat aircraft Tejas, perhaps from the closest range. So today is the first episode, Thursdays with Tejas, and we're happy that we are launching this series on the eve of Guru Kalam's birthday that falls tomorrow, October 15. The format of this particular series, as of now what we decided is very simple. We will have roughly around 15 to 16 minutes of discussion with Dr. Kota, and he has already decided what needs to get into this particular series episode after another. After the 16 minutes of chat, there will be a 2-minute segment for Tejas fans across the globe. Please remember that Tejas fans across the globe. We will give opportunity for people to join us during the shoot if they can come. They can come down. Otherwise, we will make arrangements to tune you in wherever you are. After these 2 minutes of fan time, every episode will have an update of Tejas for a minute. So all put together, Hamara Tejas series that will come to you every Thursdays will be around 20 minutes. And remember, we have the first partner, State Bank of India, and we hope more people will come forward to support this mega series set to spread across India. We will be moving cities after cities eventually, capturing heroes, telling the stories. So the first series today episode, Dr. Kota and me will be talking about technology.
Hello, Anand.
Yes, sir.
So we are finally ready for the takeoff.
Finally ready for the takeoff, and we are taking off with technology on board.
Wonderful. This is the finest thing we can start with.
So, Dr. Kota, when you talk about Tejas technologies, what are those key technologies that come into your mind?
LCA is a powerhouse of technology. In fact, we graduated from a first generation technology to 4+ generation technologies. The key technologies which makes LCA what it is today, okay, is one is the composites airframe. The airframe is totally different from what we have made all these years.
So the first thing is composites.
Composites.
Yeah.
And this aircraft, 90% of the surface area is composite.
All right.
Only 10% is metal surface, is in the hot end. Okay, rest of them are advanced carbon composites. And the important thing here is, when we started the project, we had zero knowledge of the technology.
So nowhere in India we had used.
Nowhere.
So composites were not used for any of the
nowhere
programs.
there. Nor any aircraft which Indian Air Force has bought had anything worthwhile technology.
So I want to just ask you, sir, when India started on composites, in whichever year it is, where was the world standing in terms of?
In fact, even worldwide, they were started using the, what you call the composites in fighter aircraft. Okay, not so much in the transport aircraft and all. We had to catch up because we didn't have the technology background earlier. So LCA project had to develop the technology, integrate the technology onto the aircraft. Okay, and when we started, we were zero. Then the surface area was 90%, weight was 45% by weight.
All right.
And that was the highest that any fighter aircraft had at that time. So it was an extraordinary, what you call, jump. And also I want to tell you that when this composite technology, we took it, we had to master how to design, how to analyze, how to fabricate, and how to, what you call, tool it up, and how to inspect. Whole lot of them we mastered as a part of this program.
So a lot of emails, especially from the students doing engineering, all of that, guys have said, I was just scanning through a couple of them. There are a lot of curious questions about composites access. So which were the labs that played key role helping ADA then, and HAL of course, to get composite materials ready for the aircraft?
The premier lab, which really put an extraordinary effort to develop this technology, and some of those technologies are the first in the world. Okay, is National Aerospace Lab.
And I think, NAL always remained even till date as an unsung hero of Tejas program, isn't it? I always felt.
Their contribution to composite technology is extraordinary. In fact, there is a very interesting episode I must tell you.
Yeah.
That the whole wing, if you see here, it is made out of composites.
Okay.
The whole front fuselage, the center fuselage, the vertical fin, the rudders, controls, all are made out of composites.
All right.
Okay. And I wonder whether there is any other aircraft with so much of composites. It's only now the transporter, civil transporter like 787, they started having.
And what about the drop tanks?
The drop tanks are also composites.
Okay, so from the beginning itself?
From beginning. From day one we made a composite because that's what gives the strength, makes it lightweight and all that kind of a thing. I want to talk a little bit about that vertical fin.
Okay.
It's a single piece.
All right.
We used to make out of metal large number of parts, assemble them together. It is molded in a single piece.
Okay.
Okay. And there is a rudder here. It's also a single piece. And there is a shaft here.
All right.
Even the shaft is made out of composites.
Okay.
First, we made out of what you call titanium.
Okay.
Okay. But titanium is a very material. It takes too long a time and takes a lot of effort, costly. So the titanium was replaced with composite today.
Sir, I want to interrupt and ask you, for a first timer who is watching our program, forget whether he's an engineering student or it could be a housewife, doctor, anyone. How do you put it in layman's term? What is a composite?
See, in a metal aircraft, you basically take a metal sheet or a metal ingot and all, machine it and put the whole thing together. And metals are very, what we call as uniform properties are there. In a composite, the properties are not uniform because you have a resin, you have a carbon fiber, you have to put them together and you have to bake them under high pressure in an autoclave.
All right.
Okay? And the other, why we are going through this complexity? Because composites are very stiff and very strong materials and very light. In fact, their stiffness, strength and all are almost like 10 times.
All right.
Okay? And they are also very light. But because we add resin, we add do all that kind of things, we get the benefit of at least 20 to 25% lighter after taking all safety precautions into one. And in an aircraft, 20 to 25%. is like winning a war and losing a war. It is as important as that.
So where do we stand now? Tejas has come this far. So where do we stand in terms of composites?
Very important and a very vital question. While we mastered the manufacturing and all that kind of using autoclaves and all, but we were buying the fiber and resin earlier.
All right.
But parallelly, we were looking for how to develop this carbon. That also has been done by National Aerospace Laboratory.
All right.
Today, the fiber is indigenous and certified for aircraft application.
Okay.
There are a large number of fiber manufacturers are there, but none of them are certified for using on an aircraft. I thought I must talk to you about other technologies which are important. Next is the flight control system.
Okay.
This is the aircraft which has an all-digital flight control system.
Okay.
See, the world has started with analog, then hybrid, then digital. We went straight to the digital, and we got the benefit of that. Okay, and there are two major components of that. One is the hardware, the actuator, the computers. Second is the control law.
Okay.
It is the control law which actually determines how the aircraft will fly as per the commands of the pilot.
Okay.
And that is the control law which makes it a, what you call, a combat aircraft.
Okay.
This is a prohibited, what you call, technology from US and
Other countries.
They said they will not give anything. So we had to develop this one. We formed, Dr. Kalam formed a national controller team.
Team.
It had the DRDO lab people, the ADA people, the HAL, the NAL, and it was positioned at NAL, and some lot of support from academic institution. I'm happy to tell you, the team has developed the controller to such a, what you call, wonderful level, that when we tested this controller on a modified F-16 aircraft, in those days we were in good communication. The Pentagon pilot who flew this, he said the F-16 flies better
On
with LCA control.
loss,
I thought that means we have really reached a, what you call, a level whereby the pilots become confident, the engineers become confident, and today every pilot who has flown this aircraft vouches for the extraordinary handling qualities of this.
And the great claw names are like from Shyam Shetty to the Girish to...
Girish, all of them.
And who were there before that?
No, before these people were working on Srinath Kumar.
Okay.
He was the head of the control, national controller team. And an extraordinary work he had done, extraordinary person he was.
Okay.
This is the, and the hardware. All that computers and all. There was in 1998, there was a US sanctions. There was a, what you call, some cooperative work with the US industry. They stopped totally.
Okay.
Okay. So then what happened? We regrouped, put the whole thing together and worked day and night, and the complete software, hardware, everything was developed and tested, integrated, and the test facility itself is a very, very complex thing. We call it as an iron bird. It is so complex that itself took us years to develop it and calibrate it and get it certified. Even a simple test facility has to be certified before you can use it, and this is a very complex one. And my opinion, the test facilities were as complex as the aircraft equipment itself. And this is a major achievement. But I want to add one more thing. The actuators we were importing.
Okay.
But today, that actuator has been developed totally in India.
And who has developed it?
The Vikram Sarabhai Space Center did the development. Industries like what you call Godrej and all, they manufactured it. And today the aircraft, Mark 1A and all of them indigenous, they will have all indigenous actuators. And they are not ordinary actuators. There is only, maybe we are the second country in the whole world who could drive those servo valves, called direct drive valves. Nobody else.
So two technologies we spoke. So what's the next one?
The third one, which I thought is important to make this aircraft as a weapon system, is the digital avionics and the digital cockpit.
Okay, so now we spoke about the fly-by-wire system, right?
Now, we spoke that. We talked about composite. Now let us look at the digital avionics. The cockpit of LCA is totally digital. There are no discrete. Even standby instruments are also digital. Okay? Maybe the first aircraft of that generation, of this generation, who had everything digital.
So, sir, the youngsters who are watching, what were the forefathers of digital cockpits? Before that, what were the kind of?
For example, Indian Air Force had Mirage 2000, even today they have Mirage 2000, they have Su-30, they have Jaguar, they have MiG other aircraft, MiG-29. None of them have digital cockpits. See, this becomes important for a fighter aircraft because this is a multi-role aircraft. It in air-to-air mode, in air-to-ground mode, air-to-sea mode, and it should be able to flip over from one mode to the other mode.
Okay.
This is a truly designed multi-role aircraft. Okay, there are other aircraft who have been converted and all. This is a design from day one as a multi-role. And this, what you call avionics, integrates the sensors like radar, electronic warfare system and all, and integrates in this aircraft. Specialty is it integrates also the utility system like hydraulics, the fuel system, the landing gear, all of them are electronically controlled.
Okay.
This is the first aircraft we have this kind of capability. It gives tremendous advantage to that. So this also the digital avionics also enables what you call as a weapon management system. Aircraft becomes a weapon system.
Okay.
Okay. And all weapons are integrated digitally. Okay. And all software, everything is done. This makes it as a really a formidable and a powerful weapon system.
So
that is what happens.
what is in the next technology we talked to?
The other one is the utility systems, which are computer controlled.
Okay.
Earlier, all the aircraft, including what Indian Air Force is operating and all that, they are not what integrated with avionics and all. As a result, their monitoring, their management is suboptimal.
So you call all this put together as utility systems? Okay.
Utility systems, because that they are the one which run the aircraft.
Okay.
If you don't have fuel, if you don't have hydraulics, you don't have landing, how will you make this aircraft work?
Okay.
Okay. And so they play a very important role, and they are also made now computer control. The benefit is from there we can complete health of the aircraft also.
Can we monitor?
We can monitor.
Okay, interesting.
Okay, that's the next step. But all the ingredients that are required are already there. In fact, the LCA Mark II and all of them will have that kind of capability. That's what we are doing now. And I thought I want to add one important thing, that is the shape of the aircraft.
Okay.
Size-wise, this is the smallest fighter you have been talking,
Yes.
which is there. But the shape also very interesting.
Okay.
This is a compound delta configuration.
Okay.
And it is an unstable aircraft. If you don't have flight control system, if our control system fails, aircraft will go out of control in a matter of 300 milliseconds.
Okay.
Okay. And this has been designed in this way. It is not that, because that makes the aircraft highly agile and highly maneuverable, which is a key characteristic of a what you call an air superiority fighter. This has what you call a compound delta configuration. Maybe only fighter in the whole world which has this configuration. And we had spent enormous effort in hundreds of such alterations, variations and all. Finally came to that. It gives you the right kind of performance at a reasonable cost.
So,
Okay.
I wanted to ask you one thing. Perhaps we can make it as the next episode. My favorite topic, weapons. A lot of things have been written about, we have read many things, a lot of comparisons. When it comes to the might of Tejas weapons, the Chinese JF-17, China, Pakistan, whatever, when you compare Tejas with JF-17,
It is
where does it?
it's a very important and a vital question, because that is what differentiates the Tejas from other aircraft.
My production head, Murali, is already giving a signal saying time up for the first episode. So that answer, the much awaited, perhaps in the next episode. So the young fellows, we have a special guest who came to Bangalore just in time from Vijayawada, a law student. He did his graduation, now he's pursuing law. Hamara Tejas, huge fan. Funny Dheeraj. So here is an opportunity for all youngsters across the globe. I told in the beginning. So here is what Funny asked Dr. Kota Harinara.
Namaste, sir.
Dheeraj, you are from Vijayawada?
Yes, sir.
Oh, good. Nice place to there. So you have any question to ask?
My question to you is, when you are developing such complex technologies, when do you decide and how do you decide which technology gets integrated and which technology gets rejected?
Good question. We normally do a feasibility study to see the viability, the what minimum technology required. But during project definition phase, we look at all the systems that required, what are the requirements to be finalized, and then we do alternate concepts, ideas. So during this phase, we freeze the configuration, freeze the systems, freeze the size, shape, and all the tail cost. So that is how, in a complex system, the whole development, start of development takes place. So that is the way to move forward. Thank you. So nice to see. I'm happy. Keep your interest on, and I'm glad so many of you are showing so much of interest in this project.
I can safely say that most of Vijayawada is happy that
great,
you are
great,
interacting with
good.
us today.
All the best. Do
you,
well.
sir. Thank you.
Okay.
Sir. Namaste.
Now, time for the all-important Tejas update. So, this will be the third segment of every episode. So, at the end of it, we will give you a small update, not going very deep into anything, but just what you need to know, especially the youngsters. So, we understand that the air-to-air refueling trials with drop tanks in different configuration has been successfully completed on one of the test platforms with both the tanker and buddy aircraft. So, buddy aircraft in this case was a Su-30 MKI, and the trials were held somewhere in Mongolia. So, that has been successfully completed. This means, it's a very significant step as the project now moves ahead, forward. Tejas Mark 1A. So, this is a very significant thing, these trials. So, that's it, folks. I hope you guys enjoyed the first episode of Hamara Tejas, along with Dr. Kota Harinarayana. Please do remember to send your feedback. Please do remember to write to us in whatever form. All those who write letters, I would personally want you guys to write letters. The address is given here to Tarmac Media House, or you can even email. Dr. Kota is very particular that all the messages should be answered. There could be some surprises to some best letters. We'll send you some goodies. Young fellows, thank you for watching this program. Thank you for supporting Tarmac Media House. And I also want to finally, one more time, thank State Bank of India for partnering with us. We need more support. That's it. Stay inspired, stay safe, keep the tricolor always pinned to the heart. Help others wherever possible you can. Lock on to your dreams. Jai Hind.